We can't deny the impact COVID-19 has had on our lives. Overwhelming hospitals, forcing us all in our homes, even making us ration out toilet paper.
What?
Fortunately, science helps us understand this pandemic, allowing us to protect, prevent, and possibly even solve this global health crisis.
Hey Kyle, that's cool and all, but where did COVID even come from?
Let's find out.
Meet SARS-CoV-2, the virus causing COVID-19. Despite speculation that this virus came from a lab, there is expert consensus that points to a natural origin. So let's look at how viruses mutate in nature.
But before a virus can mutate, it first has to enter your cells.
How does it do this? First, SARS-CoV-2 uses spikes made of protein to bind with receptors on your cell's surface. These receptors normally attach with signaling molecules, allowing cells to communicate. Once attached, the cell is tricked into letting the virus in.
Its mission isn't over yet. It still needs to make more of itself.
This is where RNA comes in. In cells, RNA connects the DNA with the ribosomes. Ribosomes make proteins, which are essential to life itself. Proteins send signals, start reactions, and even fight off infections. To know what proteins need to be made, ribosomes receive instructions from messenger RNA on the DNA's behalf. SARS-CoV-2 also has RNA, but its RNA takes over your ribosomes to make its own proteins, which will end up as viral skeletons. To turn these skeletons into working viruses, we now need to fill them with RNA. RNA uses an enzyme called RDRP to take code from an old strand and form a new one, in a process called RNA replication. Occasionally, RDRP will break off from its original template, A, and finish coding on a different one, B. The new RNA strand now has code from both templates, A and B, a combination of sorts, RNA recombination. But what does this have to do with COVID?
SARS-CoV-2 uses spikes made of protein to bind with receptors on your cell surface.
The spikes are a virus's keys. The structure of these spikes, what we call the receptor binding domain, determines what receptors a virus can bind to. Changes in RNA can alter the spike's receptor binding domain, basically creating a new set of keys for the virus. And with new keys comes new doors to unlock.
Exactly. Scientists think recombination could be why SARS-CoV-2 spike proteins evolved to bind with human receptors.
If these mutations help the virus keep infecting, they'll get passed on, and before you know it, the pandemic is all over the news.
But for now, remember that information is crucial to fighting COVID-19.
Staying informed helps arm the world with the knowledge we need to combat this global health crisis.
So thanks for staying informed.
Thanks for watching.